March the 2025 arrived with a discovery that would force astronomers to question everything they thought they knew about interstellar objects. Deep in the control rooms monitoring Mars missions, something impossible began happening. The instruments weren't malfunctioning. The data was clean, verified across multiple independent systems. And that made it so much worse. Every 6 hours and 47 minutes, like clockwork, electromagnetic pulses were hitting Mars. Not random bursts of solar radiation, not cosmic noise, pulses, repeating with a precision that made no sense for any natural phenomenon scientists could name. The Perseverance rover detected them first, its sensors recording electromagnetic spikes that shouldn't exist. Then, the orbital assets confirmed it. Mars Reconnaissance Orbiter, MAVEN, the European Space Agency's trace gas orbiter, all picking up the same signal at the exact same intervals. The pattern was too perfect. Natural processes don't work like this. Comets outgas irregularly as different parts of their surface heat and cool. Pulsars rotate with precision, sure, but they're neutron stars. Collapsed stellar cores with magnetic fields 1 trillion times stronger than Earth's. Not chunks of ice and rock drifting through space. Solar flares erupt chaotically. Magnetospheric phenomena fluctuate. Everything in nature has noise, variation, entropy creeping in at the edges. This didn't. 6 hours, 47 minutes, and approximately 12 seconds, over and over. The timing held to within milliseconds across dozens of repetitions. Instruments on opposite sides of Mars detected the pulses simultaneously, ruling out local interference or equipment issues. The signal was real. It was external, and it was impossibly regular. But here's what made scientists stop everything they were doing and stare at their screens in growing disbelief. The source wasn't the Sun. It wasn't Jupiter's magnetosphere. It wasn't some new cosmic phenomenon from deep space. When multiple observation stations triangulated the origin point, the answer came back pointing to something that absolutely, fundamentally, shouldn't be capable of producing directed electromagnetic pulses. 3I/Atlas, an interstellar comet, a ball of primordial ice and dust that had been drifting through the void between stars for millions of years, following the dead laws of orbital mechanics and nothing more. Comets don't send signals. They don't pulse with metronomic precision. They don't aim anything at planets. They're not transmitters or beacons or communication devices. They're frozen debris left over from planetary formation, following parabolic trajectories determined by gravity alone. Calling a comet active means it's venting gas and dust as sunlight warms its surface. That's it. That's the extent of comet behavior. Except 3I/Atlas was doing something else entirely. Something that violated every model, every theory, every assumption built into our understanding of what interstellar visitors are and how they behave. The comet was still millions of kilometers from Mars, approaching on its hyperbolic orbit through the inner solar system. And somehow, someway, it was sending repeating electromagnetic pulses directly toward the red planet with timing precision that would make an atomic clock jealous. The anomaly that shouldn't exist was here, and it was talking to Mars. Mars is the most watched planet in the solar system besides Earth. By 2025, humanity had built an entire surveillance network around the red planet, a constellation of sophisticated eyes and ears designed to study every aspect of the Martian environment. Orbital satellites, surface rovers, weather stations, seismometers, all working continuously to unlock the secrets of our neighbouring world. This network wasn't built to detect alien signals. It was built to study geology, atmosphere, and the ancient history of water on Mars. But on that March morning, it captured something nobody had anticipated. The Perseverance rover sits in Jezero crater, a massive impact basin that once held a lake billions of years ago. Its suite of instruments constantly monitors radiation levels, atmospheric conditions, and electromagnetic fields as part of routine environmental surveys. When the first pulse arrived, the rover's radiation and electromagnetic sensors spiked simultaneously, recording values that fell outside normal parameters but not outside the range of possible solar events. The system logged it automatically and moved on. Then, 6 hours and 47 minutes later, it happened again. Exactly the same signature, exactly the same intensity, exactly the same duration. 3 repetitions would have been written off as coincidence. 5 repetitions prompted automated alerts. By the 10th repetition, human operators were watching in real time. And by the 15th, they had begun coordinating with orbital assets. The Mars Reconnaissance Orbiter, circling the planet at an altitude of roughly 300 kilometers, detected the same pulses using completely different sensor technology. Its telecommunications equipment registered brief but distinct electromagnetic interference during each pulse window. The timing matched Perseverance's data perfectly. Then MAVEN, the Mars Atmosphere and Volatile Evolution Orbiter, confirmed it from a different orbital position. Then, the European Space Agency's Trace Gas Orbiter added its observations. 4 independent spacecraft, built by different agencies, using different instruments, all detecting identical pulses at identical intervals. The possibility of coordinated equipment failure across international space assets approached zero. Whatever was creating these pulses existed outside the instruments measuring them. The beautiful and terrifying thing about having multiple observers is triangulation. When several detectors at different locations all pick up the same signal, you can trace straight lines back from each detector through space and find where those lines intersect. That intersection point is your source. Technicians ran the triangulation calculations, expecting the lines to point at the Sun, or perhaps to some region of Mars's magnetosphere, creating a natural oscillation. Instead, the lines converged on empty space millions of kilometers away. Empty space that wasn't quite empty. 3 I-Atlas occupied that exact position, drifting on its hyperbolic path through the inner solar system. The interstellar comet, the frozen wanderer from beyond our Sun's influence, sat precisely at the origin point of the electromagnetic pulses. The math was clean. The geometry was undeniable. Somehow, impossibly, the signal was coming from the comet itself, and it was aimed directly at Mars with a precision that natural processes simply cannot achieve. The data didn't make sense until someone plotted it in 3 dimensions. That's when the true impossibility became clear. Scientists working with Mars observation networks had been analyzing the electromagnetic pulses for weeks, documenting their precise timing and measuring their intensity. But timing and intensity only tell half the story. Direction tells the other half, and direction is where natural explanations began to collapse entirely. Electromagnetic radiation typically spreads in all directions from its source. The Sun blasts light and radiation outward in a sphere. Radio galaxies spray energy across vast regions of space. Even focused natural phenomena like pulsar beams sweep across the sky, like lighthouse beacons, their radiation visible to any observer who happens to be in the beam's path at the right moment. What electromagnetic radiation doesn't do, what it physically cannot do through any known natural process, is aim at a single specific target millions of kilometers away. But 3I Atlas was doing exactly that. When researchers mapped the pulse detections across all the Mars assets, a disturbing pattern emerged. Perseverance on the surface, Mars reconnaissance, orbiter on one side of the planet, Maven in a different orbital plane, Trace, gas orbiter in yet another position, all detected maximum signal strength at the exact same moment. Not sequentially, as you'd expect, if a broad beam was sweeping past Mars, simultaneously, as if the pulses were arriving from a point source aimed directly at the planet's center, washing over all instruments at once, regardless of their positions relative to each other. The geometry of simultaneous detection proved the beam was narrow, tightly focused on Mars itself. A broad electromagnetic burst from the comet's location would have reached different Mars orbiters at slightly different times as the wavefront expanded outward. The absence of any detection delay meant the energy was concentrated into a cone narrow enough that Mars, with its roughly 6,800 kilometer diameter, sat entirely within the beam. This wasn't radiation leaking out in all directions. This was targeted emission. Ground-based observatories on Earth tried to detect the pulses and found nothing. The Hubble Space Telescope, positioned well outside the Mars comet line of sight, recorded no unusual electromagnetic activity from 3I Atlas during pulse windows. Deep Space Network radio telescopes scanning the comet detected only normal solar system background noise. The signal existed only along the direct line between the comet and Mars. Everywhere else, silence. Triangulation confirmed what everyone feared to say out loud. The pulses originated from 3I Atlas's position to within a margin of error of less than 100 kilometers. Given that the comet's nucleus was estimated at perhaps 20 to 30 kilometers across, this meant the source sat somewhere on or very near the nucleus itself. Not in the coma, the diffuse cloud of gas and dust surrounding the nucleus. Not in the tail streaming behind it. The source was the comet itself, and it was pointing at Mars with a precision that demanded explanation beyond anything natural physics could provide. To understand why 3I Atlas, sending pulses to Mars, is so profoundly disturbing, you need to understand what this object is and where it came from. This wasn't some ordinary comet from our solar system's Oort cloud, making a routine passage near the Sun. This was a visitor from somewhere else entirely, an ambassador from stellar systems we will never see, carrying ice and rock that formed in alien clouds around stars whose light has never been catalogued in our databases. The discovery came in early 2025, when the Atlas survey telescopes captured an object moving through the constellation Cancer. Initial observations showed nothing particularly remarkable, just another faint smudge of light among millions. But when astronomers calculated its orbit, everything changed. The numbers revealed an eccentricity greater than 1, the mathematical signature that separates solar system natives from interstellar wanderers. This object wasn't bound to our Sun. It came from outside, falling through the dark between stars on a journey that began long before humans existed. Trajectory reconstruction tells us that 3I Atlas entered our solar system from the direction of the constellation Lyra. Though pinpointing its exact origin, star remains impossible. Interstellar space is vast beyond human comprehension, and objects drift for millions of years between stellar systems. The comet could have been ejected from a planetary system 10 light-years away, or 50, or 100. It could have been wandering for 10 million years, or 100 million. In the cold darkness between stars, time loses meaning. Nothing changes, nothing decays. The comet would have remained frozen at just a few degrees above absolute zero, its ice preserved perfectly, its interior chemistry locked in stasis. Then it fell toward our sun. Gravity is universal, and our star's influence extends roughly 2 light-years in all directions. Once 3I Atlas crossed that invisible boundary, it became trapped in the sun's gravitational well, not permanently, but temporarily. Its trajectory bent inward as solar gravity accelerated it to tremendous speeds. By the time it passed through the inner solar system, it was moving at roughly 60 kilometers per second relative to the sun, fast enough to complete the journey from Earth to the Moon in less than 2 hours. The orbital calculations show that 3I Atlas approached from above the plane of the solar system, diving downward through the planetary orbits at a steep angle. Its path brought it relatively close to Mars, passing within approximately 30 million kilometers of the red planet in early March of 2025. In cosmic terms, that's practically a graze, close enough for Mars's gravity to slightly perturb the comet's trajectory. After passing Mars, the orbit would carry 3I Atlas around the Sun at perihelion, before slinging it back out toward interstellar space, never to return. Except something happened that changed everything. As the comet approached Mars, it began sending signals, and a frozen relic from between the stars suddenly became something else entirely. Scientists don't jump to extraordinary conclusions easily. The training, the culture, the entire foundation of scientific method demands that researchers exhaust every ordinary possibility before even whispering about the extraordinary. When the 3I Atlas pulses first appeared, teams around the world immediately began constructing natural explanations. They had to. The alternative was too massive to contemplate without first eliminating everything else. The most obvious explanation involved rotation and outgassing jets. Comets aren't smooth spheres. They're irregular chunks with active regions where subsurface ice gets exposed to sunlight and vaporizes violently. These jets of gas and dust can create quasi-periodic brightening as the nucleus rotates, bringing active regions in and out of view. A comet rotating every 6 hours and 47 minutes with a particularly strong jet pointed toward Mars might theoretically produce something resembling regular pulses. The model was elegant, familiar, and completely wrong. The timing precision killed it. Real comets don't maintain rotation periods to millisecond accuracy across weeks of observation. Outgassing jets create torques that change rotation rates. Surface sublimation redistributes mass, altering the moment of inertia. Real rotating bodies in space show variation, drift, irregularity. 3I Atlas showed none of these. Its pulse timing remained locked with a stability that suggested either impossible physics or something maintaining the timing actively. The directionality problem proved even more insurmountable. Outgassing jets spray material in relatively narrow cones, but they're still jets, not laser beams. The gas and dust spread as they travel, following ballistic trajectories. An outgassing jet pointed at Mars from 30 million kilometers away would create a plume hundreds of thousands of kilometers wide by the time it crossed that distance. Yet, the electromagnetic pulses showed no evidence of spreading. They remained tightly focused, hitting Mars and apparently nowhere else. Natural jets don't work that way. Some researchers proposed that Mars itself was generating the signal through interaction with the comet's plasma environment. Perhaps the comet's coma, that cloud of ionized gas surrounding the nucleus, was somehow resonating with Mars's weak magnetic field to create the pulses. This explanation failed immediately when observations confirmed the signal originated from the comet's position, not from Mars's magnetosphere. The triangulation data was unambiguous. Others suggested exotic natural phenomena. Maybe the comet was rotating so fast it was generating unusual electromagnetic fields through some kind of triboelectric effect, static electricity on a cosmic scale. Maybe it contained metallic ores that were creating natural radio emissions as they outgassed. Maybe it was interacting with the solar wind in unprecedented ways. Each hypothesis was carefully examined, modelled, and compared against observations. Each failed to explain the precision, the directionality, and the apparent targeting of Mars specifically. By late March, the natural explanation file had grown thick with rejected hypotheses. Every conventional mechanism had been tested against the data and found wanting. The scientific community found itself in the deeply uncomfortable position of having eliminated the ordinary without yet daring to name the extraordinary. Something was producing those pulses, and whatever it wasn't following any rules that natural comets are supposed to follow. The devil lives in the details, and the details of the 3I Atlas signal were absolutely demonic. Once scientists accepted that the pulses were real and not instrumental artifacts, they began dissecting the electromagnetic signature with every tool available. What they found didn't comfort anyone. Instead, each new layer of analysis made the phenomenon stranger, more structured, and harder to explain away as natural cosmic noise. The primary frequency centered on approximately 1.42 gigahertz. If that number sounds familiar, it should. That's right next to the hydrogen line, the natural emission frequency of neutral hydrogen atoms, the most abundant element in the universe. Radio astronomers call this frequency the cosmic waterhole, a metaphorical gathering place where any civilization attempting interstellar communication might reasonably broadcast. It's a quiet part of the radio spectrum, relatively free from natural interference. It's also the frequency that SETI, the search for extraterrestrial intelligence, has monitored most intensively for decades when listening for signals from distant stars. Finding an artificial signal at the hydrogen line from Alpha Centauri would be extraordinary. Finding one from an interstellar comet passing through our own solar system was something else entirely. But the frequency alone didn't prove intent. Hydrogen is everywhere in space, and natural processes involving hydrogen can produce emissions near this frequency. What mattered more was the structure of the signal itself. Each pulse lasted exactly 3.7 seconds. Not approximately, exactly. Across dozens of repetitions spanning weeks, the pulse duration remained constant to within measurement precision of less than 1 millisecond. Natural phenomena don't maintain this kind of temporal stability. Even pulsar signals, generated by rotating neutron stars with incredible rotational stability, show tiny variations due to quantum effects and starquakes. The 3I Atlas pulses showed none. The signal also had internal structure. It wasn't just a 3.7-second burst of undifferentiated radio noise. Careful analysis revealed that each pulse contained shorter subpulses, rapid variations in intensity occurring at microsecond timescales. The pattern of these subpulses repeated identically in every main pulse. It was like a fingerprint, a specific sequence of highs and lows embedded within each transmission. Random noise doesn't create identical repeated patterns. Information does. Polarization measurements added another disturbing detail. The pulses were circularly polarized, meaning the electromagnetic waves rotated as they propagated through space. Natural radio emissions are typically unpolarized or randomly polarized. Achieving consistent circular polarization requires either very specific magnetic field geometries or deliberate manipulation of the emission mechanism. The latter seemed increasingly likely. Bandwidth analysis showed the signal was remarkably narrow, concentrated within a frequency range of less than 1 kHz. Natural broadband emissions from cosmic sources spread across much wider ranges. Narrow bandwidth suggests efficient use of the electromagnetic spectrum, exactly what you'd expect from an engineered transmission trying to maximize signal clarity while minimizing energy expenditure. Every characteristic pointed in the same direction. Structure, precision, efficiency, all hallmarks of design rather than accident. The electromagnetic signature of 3I Atlas wasn't just unusual. It was speaking in the language of intentional communication. Of all the questions raised by the 3I Atlas phenomenon, perhaps the most haunting is the simplest. Why Mars, an interstellar object, whether natural or otherwise, enters our solar system and begins transmitting electromagnetic pulses? Fine. But why direct those transmissions at the fourth planet specifically? Why not Earth, teeming with radio transmissions and obvious signs of technological civilization? Why not Jupiter, the gravitational giant that dominates the system? Why Mars, cold and dead and silent for billions of years? The orbital mechanics suggest deliberation rather than coincidence. 3I Atlas didn't have to pass anywhere near Mars. Its hyperbolic trajectory brought it through the inner solar system at a steep angle to the planetary plane. Small variations in approach angle or timing would have sent it past Venus, or between Earth and Mars, or nowhere near any planet at all. Yet the comet's path carried it to within 30 million kilometers of Mars at almost exactly the moment when Mars occupied that particular position in its orbit. The statistical probability of this alignment occurring by pure chance sits uncomfortably low. Consider the timing window. Mars orbits the Sun every 687 days. Earth orbits every 365 days. The two planets align in favorable positions only periodically. 3I Atlas arrived during one of these favorable windows, when Mars was positioned such that a close approach became possible. Change the comet's arrival time by a few months in either direction, and it would have missed Mars entirely. The precision suggests either impossible luck or trajectory planning, but perhaps the most disturbing possibility involves Mars's past rather than its present. 4 billion years ago, Mars was a very different world. Orbital missions and surface rovers have built overwhelming evidence that ancient Mars possessed liquid water on its surface. River valleys carved by flowing water snake across the highlands. Delta deposits fan out where rivers once emptied into lakes. Mineral signatures testify to prolonged interaction with water. The atmosphere was thicker, the temperature warmer, the surface potentially habitable. Ancient Mars could have supported life. Then something changed. The planet lost most of its atmosphere. The magnetic field that once protected the surface from solar radiation disappeared. The water froze or evaporated or soaked into the regolith. By 3.5 billion years ago, Mars had transformed into the frozen desert we observe today. But for that first billion years, that brief window in geological time, Mars might have been alive. If 3i Atlas is scanning for life, or searching for civilizations, or conducting some kind of survey mission, ancient Mars would be exactly the kind of target worth investigating. A world that once had water, that once might have harbored biology, that represents a cautionary tale of planetary evolution gone wrong. You wouldn't send your probes to obviously dead worlds or gas giants. You'd send them to places where life could have emerged, where the chemistry was right, where the conditions once permitted biology to take hold. You'd send them to Mars, and you'd arrive precisely when and where you needed to be. Within days of confirming the signal's artificial characteristics, the scientific community activated protocols that had existed only in theory for decades. SETI researchers, who had spent careers listening to distant stars for signs of extraterrestrial intelligence, suddenly found themselves analyzing a potential contact scenario occurring not light years away, but right here in our solar system. The problem was that every assumption, every prepared strategy, every decoding framework had been built around the idea that signals would come from distant civilizations, anchored to their home stars. Nobody had seriously prepared for a message from an interstellar comet. The first attempts focused on mathematical patterns. Mathematics is often called the universal language because its truths hold regardless of biology, culture, or evolutionary history. 2 + 2 = 4, whether you're human, dolphin, or hypothetical silicon-based intelligence from Proxima Centauri. Researchers began searching the pulse structure for mathematical constants like pi, the golden ratio, or sequences of prime numbers. Prime numbers are particularly appealing because they can't result from natural periodic processes. You don't get pulsars that emit every 2 seconds, then 3 seconds, then 5 seconds, then 7 seconds. Primes scream artificiality. Initial analysis of the 6-hour 47-minute interval yielded interesting numbers, but nothing conclusive. 6 hours and 47 minutes equals 24,420 seconds. That's not a prime number, but it factors into 2 times, 2 times, 2 times, 2 times, 3 times, 509, which includes 509 as a prime factor. Was that meaningful? Maybe. Or maybe humans were pattern-seeking their way into significance where none existed. The 3.7-second pulse duration got similar treatment. 3.7 seconds is 37/10ths of a second, and 37 is prime. Coincidence or signal? The subpulse structure within each main pulse showed microsecond timing variations that some researchers claimed corresponded to the decimal expansion of mathematical constants. Others said, that's just humans finding patterns in noise, because our brains are wired to find patterns everywhere. Geometric analysis tried a different approach. Perhaps the timing ratios encoded spatial relationships, or astronomical constants. The ratio between pulse duration and pulse interval, between subpulse patterns and main pulse structure, between signal frequency and bandwidth. All these got examined for geometric meaning. Some ratios came close to interesting values, like the ratio of Earth's orbital period to Mars's orbital period, but never exactly. Close enough to be tantalizing, not close enough to be convincing. The most frustrating aspect of the decoding attempts was the sheer ambiguity. When you're trying to decode a message without knowing the encoding scheme, almost anything can look like almost anything else. Is this sequence of timing variations a binary code? A representation of atomic numbers? A star map? Instructions for building something? Or are they just the electromagnetic equivalent of a carrier tone? A signal meant only to announce presence without carrying complex information. By April, hundreds of papers circulated through preprint servers proposing different interpretations. None achieved consensus. The signal remained structured, clearly artificial, and completely opaque. 3. I-Atlas was saying something. We just had no idea what. While orbital assets provided the big picture of the 3I-Atlas signal, Perseverance rover on the Martian surface captured something that orbital sensors missed entirely. Ground truth, the data collected from actual surface conditions, often reveals details that space-based observations can't detect. In this case, what Perseverance recorded during the pulse events went far beyond simple electromagnetic detection. The rover documented physical effects that suggested the signal wasn't just passing over Mars. It was interacting with the planet in ways that had engineers seriously worried about equipment damage. The rover's radiation assessment detector, designed to measure the Martian radiation environment for future human mission planning, spiked dramatically during each pulse window. Not just electromagnetic interference in the radio frequencies, but across multiple bands, including X-rays and gamma rays. These high-energy photons shouldn't have been present if the signal was merely a radio transmission. Something about the pulses involved energetic processes that generated hard radiation as a byproduct, or perhaps intentionally. More disturbing were the effects on Perseverance's electronic systems. During the first dozen pulses, nothing unusual happened beyond the sensor readings. Then, starting with pulse number 13, the rover began experiencing glitches. Brief processor resets lasting milliseconds. Memory errors that corrupted small amounts of stored data. Navigation system anomalies, where the rover's internal gyroscopes reported impossible orientation changes. Each glitch coincided exactly with pulse arrival, leaving no doubt about the correlation. NASA engineers reviewing the telemetry data made the decision to shut down non-essential systems during pulse windows as a protective measure. The rover would continue monitoring and recording, but would suspend driving, drilling, and other operations that required full computational capacity. This precaution might have saved the mission. Other Mars assets reported similar but less severe interference, suggesting that Perseverance's surface location put it at ground zero for whatever effects the pulses were creating in the Martian environment. The magnetometer data proved most puzzling. Mars has no global magnetic field, only localized crustal magnetism in certain regions, left over from when the planet's core was still active billions of years ago. Perseverance sits in Jezero Crater, an area with relatively weak crustal magnetic field. Yet during pulse events, the magnetometer recorded brief but intense magnetic field variations, spikes reaching several hundred nanoteslas. These spikes appeared and vanished within the 3.7-second pulse duration. Between pulses, the magnetic field returned to normal background levels. Induced magnetic fields require moving charges, electric currents flowing through conductive material. The Martian atmosphere is thin, mostly carbon dioxide, not particularly conductive. The surface regolith has some conductivity, but shouldn't support the kind of current densities needed to generate the observed magnetic spikes, unless something about the pulse energy was ionizing the local atmosphere, or inducing currents through mechanisms that terrestrial physics doesn't fully account for. NASA classified portions of the Perseverance data initially, not releasing the full telemetry for several weeks. When it finally became public, the scientific community understood why. The rover wasn't just detecting a signal, it was experiencing physical effects from that signal, effects that implied power levels and interaction mechanisms far beyond what a frozen ball of ice should be capable of producing. The moment 3I Atlas began showing impossible behavior, astronomers around the world started pulling out old files on Oumuamua, the first confirmed interstellar visitor detected passing through our solar system back in 2017. That cigar-shaped object had caused controversy from the moment of discovery, exhibiting characteristics that challenged comfortable assumptions about what interstellar objects should look like and how they should behave. Now, with an apparent artificial signal coming from a second interstellar visitor, scientists began wondering if they had missed something crucial the first time around. Oumuamua never looked like a typical comet. It had no visible coma, no tail, no obvious signs of outgassing, despite passing close enough to the sun that any water ice should have started sublimating vigorously. It looked more like an asteroid, a bare rock tumbling through space. Yet, as it left the solar system, something pushed it. Precise tracking showed Oumuamua was accelerating away from the sun, slightly faster than gravity alone could explain. Something was giving it an extra boost. The mainstream explanation invoked outgassing of volatile materials more exotic than water. Perhaps the object contained frozen carbon monoxide or nitrogen, substances that sublimate at much lower temperatures and might not produce visible dust clouds. The outgassing would act like tiny rocket engines, pushing Oumuamua along its trajectory. This explanation worked mathematically and required no exotic physics. Most scientists accepted it and moved on, but a vocal minority never felt satisfied with this answer. The acceleration seemed too smooth, too consistent. Real outgassing from an irregularly shaped object tumbling through space should produce variable thrust as different surfaces heat and cool. Oumuamua's acceleration appeared steady, as if something was maintaining constant thrust despite the tumbling rotation. The object's extreme elongation also bothered some researchers. With a length-to-width ratio estimated at 10:1, Oumuamua was far more elongated than any asteroid or comet ever observed. Some proposed it might be a light sail, a thin, reflective sheet being pushed by solar radiation pressure. Others suggested more exotic possibilities. Now, with 3I Atlas apparently transmitting structured signals, those exotic possibilities didn't seem quite so exotic anymore. Research teams began reanalyzing every scrap of Oumuamua data, looking for anything that might have been dismissed as noise or instrumental artifact, back when the assumption was that interstellar objects must be natural. Radio telescope archives got searched for any unusual emissions during Oumuamua's passage. Optical data got re-examined for periodic brightness variations that might represent something other than tumbling rotation. The searches turned up tantalizing hints, but nothing definitive. Some radio observations showed brief anomalies during Oumuamua's closest approach to Earth, But the data quality wasn't good enough to confirm artificial signals. The object's rotation appeared more complex than simple tumbling, possibly indicating an elongated shape with unusual mass distribution, or possibly indicating something else entirely. The problem was that Oumuamua was already gone, racing out of the solar system at escape velocity. Whatever it was, whatever secrets it carried, it was beyond our reach now. We'd missed our chance to study it properly, and that mistake was not going to be repeated with 3I Atlas. The Fermi paradox has haunted astronomers since physicist Enrico Fermi asked his famous question over lunch in 1950. If intelligent life is common in the universe, if technological civilizations arise on even a tiny fraction of the billions of potentially habitable planets we now know exist, then where is everybody? Why haven't we detected their signals? Why haven't they visited? The galaxy is billions of years old. Even traveling at a fraction of light speed, a civilization could colonize the entire Milky Way in just a few million years. So, where are they? 3I Atlas potentially answered that question in the most unsettling way possible. They're not broadcasting from distant star systems. They're not building megastructures around their home suns. They're drifting through the galaxy as silent observers hidden inside objects we mistake for natural cosmic debris. They've been here all along. We just didn't recognize them. The idea isn't new. Physicist Ronald Bracewell proposed it back in 1960, suggesting that advanced civilizations might send autonomous probes to nearby star systems rather than attempting expensive, slow interstellar travel themselves. These probes would be cheaper, more practical, and could operate for geological timescales. They'd arrive in a system, position themselves somewhere observable, and wait. When signs of technological civilization appeared, radio transmissions, or atmospheric pollution, or nuclear detonations, the probes would activate and attempt contact. The problem with the Bracewell probe hypothesis always centered on where to look. Space is unimaginably vast. Even within our solar system, finding a probe sitting quietly in some stable orbit seems nearly impossible unless we stumbled across it by accident. Researchers proposed likely parking spots like the Lagrange points, where Earth and Sun's gravity balance, or the Lagrange points of Earth and Moon. Searches of these regions found nothing but natural space debris and our own satellites. But nobody seriously considered that the probes might not be sitting still. Nobody imagined they might be disguised as comets, drifting through the galaxy in vast numbers, occasionally falling through star systems on hyperbolic orbits that give them close looks at any planets present. From the outside, they'd appear completely natural. Spectrographs would show water ice, carbon compounds, silicates, exactly what you'd expect from cometary material. They'd follow ballistic trajectories determined by gravity. They'd outgas as sunlight warmed their surfaces. They'd be invisible until they chose not to be. The math actually works frighteningly well. If even 1% of the objects we classify as interstellar visitors are actually probes, the galaxy could be saturated with monitoring devices. Millions of them drifting between stars, catching gravity assists from planetary systems, gradually mapping every world that might harbor life. The transit time between stars at comet velocities is measured in hundreds of thousands or millions of years. But what's time to a machine? What's patience to an intelligence that thinks in geological epochs? 3I Atlas might be one probe among millions, a single node in a galactic surveillance network so vast and so old that the civilizations that built it might not even exist anymore. The probes could be archaeology, ancient relics still functioning long after their creators died out, still following programming that nobody remembers writing, still watching, still waiting, still reporting back to receivers that may or may not be listening. Looking at 3i Atlas is like looking in a mirror. If that mirror reflects back what we ourselves have already tried to do. Humanity has sent exactly 4 spacecraft on trajectories that will eventually leave the solar system and drift through interstellar space for millions or billions of years. Pioneer 10 and 11, launched in the 1970s, each carry a gold anodized aluminum plaque showing human figures, the position of Earth relative to pulsars, and the structure of the solar system. Voyager 1 and 2, also launched in the 70s, carry golden records containing sounds and images from Earth, a message in a bottle meant for any civilization that might intercept them. The Voyager golden records represent humanity's most ambitious attempt at interstellar communication. Scientists led by Carl Sagan curated 116 images, greetings in 55 languages, natural sounds from Earth, including thunder, wind, and animal calls, and 90 minutes of music spanning cultures and centuries. The records include instructions for playback etched onto their surfaces, diagrams showing how to extract audio and video information from the grooves. Everything was designed to be as universal as possible, using physical constants and mathematical relationships that should be recognizable to any technological civilization. But here's the uncomfortable question. If an alien civilization found Voyager drifting through their star system thousands of years from now, would they recognize it as artificial? The spacecraft is small, just a few meters across. From a distance, it would be just another piece of space debris, a tiny speck reflecting sunlight. Its radio transmitter died decades ago when its plutonium power source decayed. It's now completely inert, following a ballistic trajectory determined purely by gravity, and its last trajectory correction decades ago. It looks dead because it is dead. Only a close visual inspection would reveal the geometric shapes, the golden record, the evidence of technological origin. Now imagine that same scenario in reverse. An interstellar probe enters our solar system, perhaps sent millions of years ago by a civilization that wanted to explore nearby stars. It's designed to look like a natural object to avoid alarming any primitive civilizations it encounters. It's covered in ice and rock, shaped irregularly like an asteroid or comet, following a trajectory that appears completely natural. It would be invisible to us until it chose to activate, until it detected something worth investigating, something like radio transmissions, something like nuclear detonations, something like robotic explorers landing on Mars. The timescales make this even more plausible. Voyager 1 is currently moving at about 17 kilometers per second relative to the Sun. At that speed, it would take roughly 75,000 years to travel the 4.2 light years to Proxima Centauri, the nearest star to our Sun. 3i Atlas is moving at 60 kilometers per second, nearly 4 times faster. A probe traveling at those speeds could cross between neighboring star systems in 20,000 years, could visit dozens of systems in 1,000,000 years, could explore an entire galactic neighborhood given enough time. We sent our own primitive probes into the void, hoping someone might find them someday. Perhaps someone else had the same idea, but with better technology, better camouflage, and a much longer head start. Perhaps we're seeing what our own voyages would look like if we'd launched them millions of years ago instead of 50 years ago. The 3I Atlas phenomenon split the astronomical community down the middle in ways that haven't been seen since the debates over continental drift or the existence of black holes. On one side stood researchers who looked at the data and saw compelling evidence of artificial origin, of technology, of intelligence. On the other side stood those who insisted that extraordinary claims require extraordinary evidence, and that no matter how strange the observations seemed, natural explanations must exist even if we haven't found them yet. The battle lines formed quickly, and the fighting got ugly. Academic careers live and die on reputation. Publishing a paper proposing extraterrestrial technology sounds exciting until you realize it makes you unemployable if you're wrong. Tenure committees don't look kindly on scientists who chase sensational ideas without ironclad proof. Grant agencies don't fund research into alien artifacts when terrestrial problems need solving. The professional incentive structure of science heavily penalizes anyone who strays too far from mainstream consensus, even when the data suggests the mainstream might be missing something enormous. Several prominent astronomers who publicly argued for the artificial hypothesis found their next grant applications rejected. Not explicitly because of their 3I Atlas work. The rejection letters never said that, but the correlation was obvious. Research proposals that had sailed through review processes in previous years suddenly got criticized for methodological concerns or lack of broader impact. Conference invitations dried up. Journal editors started requesting additional peer reviewers for papers mentioning artificial origin scenarios, and those extra reviewers tended to recommend rejection. The pressure worked in reverse too. Scientists who maintained that natural explanations would eventually emerge faced accusations of close-mindedness, of refusing to follow evidence where it led because of ideological commitment to naturalism. Social media lit up with arguments between researchers who should have been collaborating. Academic Twitter threads devolved into name-calling. Conference presentations turned confrontational, with question periods becoming platforms for hostile cross-examination rather than scientific discourse. The peer review process became a battlefield. Papers proposing artificial origin got rejected from major journals, with reviewers claiming insufficient evidence or inappropriate speculation. Papers proposing natural mechanisms got criticized for ignoring obvious contradictions in the data. Some journals stopped accepting 3I Atlas papers entirely, claiming the topic had become too controversial. Others created special issues dedicated to the phenomenon, leading to accusations of sensationalism and abandoning editorial standards. Younger researchers faced impossible choices. The 3I Atlas data was fascinating, potentially career-defining if you got it right, but also career-ending if you got it wrong, or if the scientific establishment decided your conclusions were unacceptable. Graduate students working on 3I Atlas projects found themselves counseled by advisors to focus on safer topics. Postdocs seeking faculty positions learned not to mention their signal analysis work during job interviews. The very people with the most to gain from studying something genuinely revolutionary had the most to lose professionally if they pursued it. Meanwhile, the pulses continued. Every 6 hours and 47 minutes, like clockwork, 3I Atlas sent its signals to Mars. the comet didn't care about academic politics, or peer review, or tenure decisions. It just kept transmitting, indifferent to the chaos it was causing in the scientific community, trying desperately to understand what it was and what it wanted. By mid-April of 2025, the astronomical community had mobilized the most intensive observation campaign ever directed at a single solar system object. Whatever 3i Atlas was, wherever it came from, and whatever it wanted, scientists were determined to gather every possible piece of data before the comet completed its passage through the inner solar system and disappeared back into interstellar space. Time was running out. The window of opportunity to study an active interstellar visitor at close range might not come again for decades or centuries. Every major telescope on Earth and in space that could observe 3i Atlas was redirected to the target. The Hubble Space Telescope cleared its observation schedule, bumping other projects that had been planned for months. The James Webb Space Telescope, positioned at the second Lagrange point far from Earth, trained its infrared instruments on the comet to measure temperature distributions and search for thermal anomalies. The Atacama Large Millimeter Array in Chile, actually an array of 66 radio dishes working together, began continuous monitoring of radio emissions from the comet's position. Ground-based optical telescopes joined the campaign from observatories scattered across every continent. Mauna Kea in Hawaii, Cerro Paranal in Chile, the Canary Islands, South Africa, Australia, all contributed observations during their respective nighttime hours, creating nearly continuous coverage. Amateur astronomers with backyard telescopes added their data, measuring brightness variations and tracking the comet's position against background stars. Citizen science projects recruited thousands of volunteers to help analyze the flood of incoming images and spectra. The coordination effort resembled wartime mobilization more than typical astronomical research. Dedicated communication channels allowed researchers to share data in real time. Cloud servers archived observations from dozens of facilities. Machine learning algorithms scanned the data, looking for anomalies, unexpected changes, anything that might provide clues about the comet's nature. The data volume grew exponentially, reaching petabytes within weeks, more information than any single research group could analyze alone. Spectroscopic observations received highest priority. Every telescope capable of splitting light into component wavelengths focused on capturing detailed spectra of the comet. Scientists wanted to know exactly what elements and molecules made up the coma and nucleus. Water vapor showed up as expected, along with carbon dioxide and carbon monoxide. But something else appeared in the spectra too, emission lines that didn't match any known molecule. The lines were weak, barely above detection threshold, but they appeared consistently across independent observations from multiple facilities. Either instruments around the world were experiencing the same systematic error, or 3i Atlas contained chemistry that didn't fit standard comet composition models. Radar observations from planetary radar facilities bounced radio waves off the nucleus, measuring its size, shape, and rotation. The return signals showed a roughly spherical object about 25 kilometers in diameter, smaller than initial estimates suggested. The rotation period measured 18.3 hours, not matching the pulse interval at all. Whatever was creating the 6-hour 47-minute pulses, it wasn't tied to the nucleus rotation. The object was spinning one way and broadcasting on a completely independent schedule, as if two separate systems were operating simultaneously. One natural, one decidedly not. Light tells stories. When astronomers split light from distant objects into component wavelengths, creating spectra, they're reading chemical fingerprints left by atoms and molecules. Every element produces unique emission and absorption lines at specific wavelengths, patterns as distinctive as barcodes. Hydrogen produces lines in one pattern. Oxygen produces different lines. Carbon, nitrogen, silicon, iron, each element has its signature. Spectroscopy lets us determine what distant objects are made of without ever touching them. It's one of astronomy's most powerful tools, and when applied to 3I Atlas, it revealed something deeply wrong. Normal comets show predictable spectral patterns. Water vapor dominates, producing strong emission lines in the ultraviolet and infrared. Carbon monoxide and carbon dioxide appear as the comet approaches the Sun, and these more volatile ices begin sublimating. Cyanogen, hydroxyl radicals, various organic molecules, all show up in characteristic patterns that match laboratory measurements and theoretical predictions. Comet spectra are busy, filled with lines from dozens of species, but they're familiar. We've studied hundreds of comets over decades, and their chemistry follows understood patterns based on how the solar system formed 4.5 billion years ago. 3I Atlas showed the expected lines. Water was there. Carbon dioxide was there. The standard roster of comet molecules appeared right on schedule as the comet warmed during its approach toward the Sun. But mixed in with the familiar signatures were 3 emission lines that nobody could identify. The lines appeared at wavelengths of 412 nanometers, 637 nanometers, and 918 nanometers. None of these matched any known atomic or molecular transition in any database. None corresponded to common contaminants or instrumental artifacts. The lines appeared in spectra taken by different telescopes using different instruments, ruling out equipment-specific errors. At first, researchers assumed the lines must be some exotic molecular transition, perhaps from organic compounds not previously observed in comets. Complex organic molecules can produce unusual spectra, and interstellar chemistry might create compounds that solar system comets don't contain. Teams began modeling possible molecular candidates, running quantum chemistry calculations to predict what molecules might produce emission at those specific wavelengths. Nothing fit. Every plausible organic molecule either produced lines at wrong wavelengths or required physical conditions that couldn't exist in a comet's coma. The isotope ratios added another layer of strangeness. Isotopes are versions of elements with different numbers of neutrons in their nuclei. The ratio between different isotopes varies depending on where and how material formed. Solar system objects show isotope ratios that reflect the composition of the molecular cloud that collapsed to form our Sun and planets. Measurements of the hydrogen isotope ratio in 3I Atlas's water vapor showed values that fell outside the range observed in any solar system comet. The deuterium to hydrogen ratio was too high by about 30%, suggesting the water formed in a colder, more deuterium-enriched environment than our Sun's birth cloud. This wasn't necessarily proof of artificial origin. Interstellar objects should show different isotope ratios because they formed around different stars under different conditions. But combined with the unidentified emission lines, the strange isotope ratios, and the electromagnetic pulses, the spectroscopic data painted a picture of an object that wasn't quite what it appeared to be. The chemistry was almost right, but not quite. Like someone had built a convincing replica of a comet, but couldn't perfectly match every detail of natural composition. Not everyone was ready to abandon natural explanations. Even as the evidence piled up, pointing toward artificial origin, a determined group of researchers continued searching for exotic natural phenomena that might explain 3I Atlas without invoking intelligence or technology. Science has a long history of discovering natural processes that initially seemed impossible. Phenomena so strange, they challenged fundamental assumptions about how the universe works. Perhaps 3I Atlas was simply the latest addition to that list, a natural object behaving in ways we hadn't encountered before because we'd never observed this particular combination of circumstances. The magnetar interaction hypothesis proposed that 3I Atlas might have passed close to a magnetar, a neutron star with magnetic fields billions of times stronger than Earth's, at some point in its interstellar journey. Magnetars can induce powerful magnetic fields in nearby objects, and perhaps the comet's interior contained metallic cores or ferromagnetic materials that became permanently magnetized during such an encounter. These internal magnetic structures might interact with the solar wind in unusual ways, creating the observed electromagnetic emissions. The problem with this hypothesis was the directionality and precision. Natural magnetic phenomena don't aim. They don't maintain microsecond timing accuracy across weeks of observation. Another proposal suggested that the comet might contain exotic ices we'd never encountered before, materials that form only under extreme conditions found in certain stellar environments. Perhaps a type of clathrate, a cage-like structure where molecules of one substance trap molecules of another, could release stored electromagnetic energy in periodic bursts as the clathrate structure broke down under solar heating. Laboratory attempts to create clathrates with the required properties failed. No known combination of molecules could store and release energy with the observed characteristics, but perhaps the right combination simply hadn't been tested yet. The rotating dipole model took a different approach. If 3I Atlas contained a rapidly rotating mass with an asymmetric distribution of charged particles, it might generate a rotating electromagnetic dipole similar to a pulsar but on a much smaller scale. The rotation would sweep the emission beam across space, and if Earth and Mars happened to lie in the beam path, they would detect regular pulses as the beam swept past. This explained some observations, but failed spectacularly on others. Pulsars show Doppler shifting of their signals due to rotation. 3I Atlas showed none. Pulsars emit across broad frequency ranges. 3I Atlas transmitted in a narrow band at the hydrogen line. Perhaps the most creative natural explanation involved quantum vacuum fluctuations, amplified by unknown conditions in the comet's composition. Quantum mechanics allows for temporary violations of energy conservation at tiny scales, virtual particles popping into existence and annihilating almost instantly. Under extreme conditions, these fluctuations might become macroscopic, creating observable effects. The math was speculative at best, requiring physics that existed only in theoretical papers. Critics pointed out that invoking unknown physics to explain observations isn't meaningfully different from invoking unknown technology. Both are appeals to ignorance dressed up in scientific language. Each natural hypothesis faced the same fundamental problem. Individually, some observations might be explainable through exotic but natural processes. But all the observations together, the precision timing, the directionality, the signal structure, the spectroscopic anomalies, the targeting of Mars specifically, explaining all of it, naturally required stacking improbability on top of improbability until the combined scenario became less likely than the alternative everyone was trying to avoid. What if 3i Atlas wasn't sending information at all? What if it was delivering something physical, something biological, and the electromagnetic pulses were just a byproduct or targeting mechanism? The panspermia hypothesis suggests that life spreads through the cosmos not by arising independently on each world, but by being transported between star systems on comets, asteroids, and dust grains. Microorganisms, spores, or complex organic molecules survive the journey through interstellar space frozen in ice, protected from radiation by meters of rock, waiting for the right conditions to thaw and become active again. The idea isn't as wild as it sounds. Experiments have shown that certain bacteria can survive years in the vacuum and radiation environment of space. Tardigrades, microscopic animals known as water bears, can enter a desiccated state where they withstand temperatures near absolute zero, vacuum, and radiation doses that would kill almost any other organism. Complex organic molecules, including amino acids, have been found in meteorites and comets, proving that the building blocks of life can survive interplanetary and potentially interstellar journeys. Panspermia solves one of biology's hardest problems by explaining how life might spread throughout the galaxy without requiring it to arise independently in each location. But there's a difference between random panspermia and directed panspermia. Random panspermia happens by accident when impacts eject material from a planet's surface, and that material eventually falls onto another world. Directed panspermia is deliberate, a civilization intentionally seeding other worlds with life either to preserve their biology beyond their own extinction or to prepare planets for future colonization. If directed panspermia is the goal, you'd want to target worlds where life might take hold, planets with liquid water, organic chemistry, and protection from excessive radiation. You'd want to target places like ancient Mars. The electromagnetic pulses could be part of a delivery system. Perhaps they're breaking down molecular structures in the Martian soil, creating conditions favorable for whatever biological payload the comet carries. Perhaps they're activating dormant organisms frozen in the comet's ice, triggering metabolic processes that have been suspended for millions of years. Perhaps they're communicating with something already on Mars, molecular machines or synthetic biology that was delivered in an earlier pass and has been waiting in the regolith for the signal to begin reproduction. Biological analysis of Martian samples brought back by future missions might find something unexpected. Organisms with DNA that doesn't match Earth biochemistry, proteins using amino acids in the wrong configurations, metabolism based on chemistry that never evolved on Earth, or, even more disturbing, organisms with technological components, cells that contain synthetic molecules, or nanostructures that couldn't arise through natural selection. The boundary between biology and technology might be artificial, a distinction we make because our own technology is crude and mechanical. Advanced biotechnology might be indistinguishable from life itself. The timing supports this scenario disturbingly well. 3. I-Atlas arrived when Mars was in the right position, approached close enough for efficient delivery, and began broadcasting at frequencies that might interact with organic chemistry or wake-dormant systems. If it's a life-seeding mission, it's executing perfectly. The pulses continue on schedule. The trajectory carries the comet past Mars at optimal distance. Whatever it came here to do, it's doing it now, and we're watching without understanding. Witnesses to biology or technology reshaping another world while we stand helpless to intervene. There's another possibility that nobody wants to think about too carefully. What if 3I Atlas is artificial, but it's broken? What if we're watching a damaged probe, a machine millions of years old, running on degraded systems, executing programming that no longer makes complete sense because critical components have failed? This scenario is simultaneously more plausible and more disturbing than the idea of a functioning probe, because it means we might never understand what we're seeing. We'd be trying to reverse engineer intention from malfunction, meaning from noise. Interstellar space is not gentle. Cosmic rays, high-energy particles, moving at nearly the speed of light, constantly bombard anything traveling between stars. Over thousands or millions of years, these particles cause cumulative radiation damage to materials and electronics. Cosmic dust, tiny grains moving at relative velocities of tens of kilometers per second, impacts like microscopic bullets, gradually eroding surfaces and potentially puncturing containment. Temperature cycling between near absolute zero in the void and hundreds of degrees near stars creates thermal stress that can crack structures and break connections. Any probe designed for interstellar travel must account for these hazards, but no design lasts forever. Perhaps 3I Atlas was supposed to activate only when it detected technological civilizations, but its sensor systems degraded over time. Now it activates based on corrupted criteria, responding to planetary magnetic fields or solar radiation levels, instead of radio transmissions or artificial light signatures. The pulses might be attempts at communication, but garbled, missing key information that degraded memory banks once contained. The precision timing might be the only thing still working correctly. A crystal oscillator that survived when everything else partially failed. The directionality toward Mars might be a targeting system malfunction. The probe was supposed to broadcast omnidirectionally or toward Earth, where it detected radio signals, but damaged pointing controls locked it onto Mars instead. Or perhaps it's cycling through multiple targets on a programmed sequence, and we're only seeing the Mars phase. In a few weeks or months, it might shift to broadcasting toward Earth or Jupiter, or back out toward interstellar space, following a targeting list that made sense when the probe was launched, but is now executing without proper sensor feedback. The spectroscopic anomalies might represent hull degradation, exotic materials used in the probe's construction slowly vaporizing or reacting with the ice coating that accumulated during millions of years, drifting through molecular clouds. The unidentified emission lines could be from engineered materials, synthetic compounds that don't exist in nature and wouldn't appear in any database because we've never encountered them before. They're not trying to hide their artificial nature. Their camouflage systems failed long ago. We're seeing the probe naked, exposed, its true composition leaking through the ice and rock veneer. The most haunting aspect of the damaged probe theory is that it might be calling for help, transmitting a distress signal in the hope that someone, anyone, might receive it and respond. The pulses might encode coordinates, a map back to wherever it came from, or technical specifications for repair systems it hopes will understand and implement. It might be dying, systems failing one by one, and we're watching its final transmissions before it goes silent forever. Just another dead machine among the countless dead machines drifting through the galaxy. Not everything being observed about 3I Atlas made it into scientific journals or press releases. By late April of 2025, a growing gap had emerged between what researchers were seeing and what they were allowed to publicly discuss. Military and intelligence agencies in multiple countries had begun classifying portions of the data, particularly observations from assets with dual civilian and military applications. The public faced a filtered version of reality, sanitized briefings that acknowledged the phenomenon while carefully omitting details that someone in government had decided were too sensitive for general release. The United States Space Force, established just a few years earlier, took an immediate interest in 3I Atlas. Military satellites capable of detecting electromagnetic emissions across wide frequency ranges, assets normally focused on monitoring potential adversaries on Earth, were quietly redirected to observe the comet. What those satellites detected remains classified. Requests from civilian researchers to access the data got denied on national security grounds. The denial letters didn't explain what national security interests were served by hiding observations of an interstellar object, but the pattern was clear. The military knew something they weren't sharing. International cooperation broke down in ways that surprised researchers accustomed to collaborative astronomy. Normally, astronomical data flows freely across borders. Researchers in different countries routinely share observations, collaborating on papers and coordinating a telescope time. The 3I Atlas case was different. By mid-April, Chinese observatories stopped posting their data to international archives. Russian researchers stopped responding to emails requesting collaboration. American military facilities that had been sharing observations went silent. Each nation was still watching the comet, but they were no longer sharing what they saw. The data sharing breakdown hit hardest in signal analysis. Multiple facilities around the world had radio telescopes pointed at 3I Atlas, recording the pulse structure in detail. Early on, these facilities shared data in real time, combining observations to improve signal quality and eliminate local interference. Then, suddenly, several major facilities stopped participating. Their telescopes remained pointed at the comet. You could verify that through scheduling databases, but the resulting data never appeared in shared archives. Whatever they were recording was going directly to classified channels. Whistleblower reports began circulating in late April, though their reliability remained questionable. Anonymous posts on astronomical forums claimed that certain facilities had detected response signals, transmissions from 3I Atlas that changed characteristics after specific human broadcasts toward the comet. Other unverified reports suggested that military radar had tracked small objects separating from the comet's nucleus, debris, or possibly probes, heading toward Mars on independent trajectories. None of these reports came with evidence. None could be verified through public data. They might be complete fabrications, or they might be genuine leaks from people who'd seen classified briefings and felt the public deserved to know. The classification decisions created an impossible situation for researchers. Those with security clearances who'd seen the classified data couldn't discuss their findings with colleagues who lacked clearances. International collaborations fell apart because participants couldn't share all their data. Papers got submitted to journals with key sections redacted, then rejected because the arguments were incomplete. Science requires transparency, peer review, reproducibility. Classification is antithetical to the entire scientific process. Yet governments insisted certain observations were too sensitive to release, and they had the legal authority to enforce those decisions, whether scientists agreed or not. The news broke gradually, not in a single dramatic announcement, but through accumulating reports that something strange was happening in the solar system. Social media picked it up first, amateur astronomers sharing observations and speculating about the electromagnetic pulses. Scientific preprint servers published preliminary analyses that news outlets transformed into headlines. By the end of April 2025, 3i Atlas had become a household name, and the public response revealed just how unprepared humanity was for even the possibility of contact with non-human intelligence. Twitter exploded with speculation, theories, fears, and hopes. Hashtags related to the comet trended globally for weeks. Some users posted excited messages about first contact, about how this proved we weren't alone, about the scientific and philosophical implications. Others expressed fear, worrying about intentions, about invasion scenarios straight from science fiction, about humanity's vulnerability to technologies we couldn't understand or defend against. Conspiracy theories multiplied faster than fact-checkers could address them. Some claimed governments had known about alien presence for decades, and 3i Atlas was just the first admission. Others insisted the whole thing was a hoax, CGI and fabricated data meant to distract from terrestrial problems. Religious communities responded in divergent ways. Some religious leaders welcomed the discovery, arguing that a creator capable of making Earth could certainly have made life elsewhere too. That divine creation on a cosmic scale only magnified the glory of creation itself. Others struggled with theological implications, questioning where non-human intelligence fit into frameworks built around human uniqueness and Earth's special place in divine plans. Sermons addressed the topic from pulpits worldwide, offering interpretations ranging from acceptance to apocalyptic warnings about demons masquerading as aliens. Financial markets reacted with characteristic volatility. Defense contractor stocks surged on speculation about increased military spending for space surveillance and planetary defense. Aerospace companies saw their share prices jump on hopes for expanded space exploration budgets. More surprisingly, certain commodity prices showed unusual movement. Rare earth elements used in electronics spiked briefly as investors speculated about potential technological insights from studying the probe. The broader markets showed increased volatility, uncertainty about long-term implications, creating nervousness among traders trying to price in unpredictable futures. Doomsday predictions found eager audiences. Websites dedicated to end times prophecies highlighted 3i Atlas as a sign of approaching judgment. Survivalist communities reported increased activity. People stocking supplies and preparing for societal collapse they assumed would follow alien revelation. Some groups interpreted the comet as fulfillment of ancient prophecies, finding passages in religious texts that seemed to predict celestial visitors, bringing transformation or destruction. The fact that the comet would eventually pass behind the sun and disappear from view got interpreted as either returning to report back or retreating before an assault. Mental health professionals reported increased anxiety presentations related to the 3-Eye Atlas news. Helplines experienced higher call volumes from people expressing existential dread or fear about the future. Therapists noted that the phenomenon triggered various anxieties, from fear of the unknown to concerns about human insignificance in a vast cosmos potentially filled with superior intelligences. For some, the discovery was liberating, confirmation that humanity wasn't alone. For others, it was terrifying, upending assumptions about safety and cosmic isolation that provided psychological comfort, even if they'd never been true. The most contentious debate about 3-Eye Atlas had nothing to do with what it was, and everything to do with what humanity should do about it. Should we respond? Should we attempt to communicate back? Or should we stay silent, observe passively, and avoid drawing attention to ourselves? These questions sparked fierce arguments among scientists, ethicists, military strategists, and policymakers, exposing deep disagreements about humanity's proper role in potential first contact scenarios. The response faction argued that remaining silent was both futile and potentially insulting. 3-Eye Atlas already knew Earth existed, had almost certainly detected our radio and television broadcasts leaking into space for the past century, and was specifically signaling Mars, where we had active missions. Pretending we weren't here made no sense when our technological signature was already obvious. Moreover, responding might provide crucial information. If the pulses were questions, perhaps our answers would help decode their meaning. If they were attempts at establishing communication protocols, reciprocating would demonstrate our willingness to engage. Silence might be interpreted as hostility or primitive incapacity. The silence faction countered with arguments rooted in caution and the precautionary principle. We knew nothing about who or what sent 3-Eye Atlas, nothing about their intentions, capabilities, or ethics. Broadcasting our presence more actively than our passive electromagnetic leakage already did might invite attention we'd regret. History showed that contact between civilizations with vast technological disparities typically ended badly for the less advanced civilization. Native Americans didn't benefit from contact with European explorers. Why assume we'd benefit from contact with intelligences capable of crossing interstellar space? The safest choice was observation without engagement, learning what we could while revealing as little as possible about our own capabilities and vulnerabilities. A middle position suggested responding but carefully, transmitting mathematical concepts or physical constants that demonstrated intelligence without revealing specific information about Earth's location, population, or technological level. The problem with this approach was that Earth's location was already obvious to anything intelligent enough to navigate to our solar system, and our technological level was written in the radio spectrum for anyone with receivers to read. The more troubling question involved who got to decide. Did scientists who first detected the signal have authority to respond? Did governments claim this decision through sovereignty over Earth's electromagnetic spectrum? Did the United Nations have jurisdiction? The Outer Space Treaty of 1967 established principles for space exploration, but said nothing about responding to possible alien contact. No international protocol existed for this scenario, despite decades of SETI researchers requesting exactly such protocols. Each nation with transmission capabilities could theoretically respond independently, and coordinating a unified human response seemed politically impossible. Some groups didn't wait for official decisions. Several private organizations with access to radio transmitters began broadcasting messages toward 3I Atlas's position without authorization or coordination. These transmissions contained everything from mathematical sequences to cultural information to religious texts. There was no way to stop them short of physically destroying the transmitters. And even that wouldn't help, because multiple groups were transmitting from different countries. The response question had become moot. Humanity was already responding, chaotically and without unified voice. Exactly the scenario that worried ethicists most. We were shouting into the cosmos without agreement about what to say or whether saying anything was wise. May the 8th, 2025, at 14 hours 37 minutes Universal Time. That's when everything changed. The pulses from 3I Atlas that had maintained perfect 6-hour 47-minute intervals for over 2 months suddenly stopped following their established pattern. The change was so abrupt, so unexpected, that for the first few hours, researchers assumed their instruments had failed. They hadn't. The pulses were still coming, but they were different now, and that difference terrified everyone watching. The first indication came from the Mars Reconnaissance Orbiter, whose automated systems flagged an anomaly in the timing. Instead of the expected pulse arriving on schedule, nothing happened. The 6-hour 47-minute window passed with silence. Then, 7 minutes later, a pulse arrived, but it lasted 5.2 seconds instead of the usual 3.7. The frequency had shifted slightly higher, now centered at 1.43 GHz instead of 1.42. The subpulse structure that had repeated identically in every previous transmission showed a completely different pattern. Within hours, observatories worldwide confirmed the change. The pulses were still coming, still targeted at Mars, but operating on a new schedule that took analysts days to fully characterize. The interval had shortened to 5 hours 12 minutes. The pulse duration varied between 4 and 6 seconds, not randomly, but following a pattern that repeated every 7 pulses. The frequency drifted slightly between transmissions, wandering within a narrow band around 1.43 GHz. It was as if someone had changed the programming, adjusted parameters, or switched to a different transmission mode entirely. The timing of the change was impossible to ignore. The pattern shift occurred approximately 72 hours after multiple Earth facilities had begun broadcasting response messages toward 3I Atlas. The light travel time between Earth and the comet's position was roughly 8 minutes at that point in their respective orbits. Accounting for signal processing time and response formulation, 72 hours was entirely plausible as a response delay. The comet appeared to be reacting to human transmissions, adjusting its signal characteristics in response to something we'd sent. But what was it responding to? Dozens of different messages had been transmitted from various facilities, containing everything from prime number sequences to images to music. Which transmission triggered the response? Or was it responding to all of them collectively, to the simple fact that Earth had demonstrated active technological civilization? The ambiguity was maddening. We'd apparently provoked a reaction, but had no way to determine which action provoked it, or what the reaction meant. The new pulse pattern resisted decoding just as thoroughly as the original. Analysts applied every technique used on the first set of transmissions, looking for mathematical constants, geometric relationships, prime number sequences, anything that might reveal meaning. The varying pulse durations suggested binary encoding, short pulses as zeros, and long pulses as ones. But extracting meaningful data required knowing how to group the bits, where messages started and ended, what the bits represented. Without a key, without context, the patterns remained opaque. More disturbing were the physical effects at Mars. Perseverance rover reported stronger electromagnetic interference during the new pulses, more frequent system glitches, and on 2 occasions, complete communication blackouts lasting several minutes. The radiation spikes were more intense, reaching levels that would be dangerous for unshielded humans. Mars Reconnaissance Orbiter experienced navigation errors requiring manual correction from Earth. Whatever 3I Atlas was doing, it had increased the power output or changed the emission characteristics in ways that affected nearby systems more strongly. The pattern change demolished any remaining arguments that this was natural phenomena. Natural objects don't change their behavior in apparent response to external signals. They follow physics, blindly and consistently. 3I Atlas was watching, listening, and responding, and we had absolutely no idea what we'd just said to it or what it was now saying back. The Mars orbital environment began showing anomalies that went far beyond simple electromagnetic interference. Starting in mid-May of 2025, instruments monitoring Mars's space environment detected phenomena that had no precedent in decades of Mars observation. Something was changing in the region around Mars, and 3I Atlas seemed to be the cause, or at least the trigger, for changes that suggested Mars itself might be responding to the comet's signals in ways that challenged everything scientists understood about planetary physics. The first anomaly appeared in magnetometer data from spacecraft orbiting Mars. Mars lacks a global magnetic field, its core having cooled billions of years ago and stopped generating the dynamo that once protected the planet from solar wind. Only localized crustal magnetism remains, fossil magnetism locked into rocks when the global field still existed. These crustal magnetic fields are weak, stable, and thoroughly mapped. They don't change, except now they were changing. During pulse windows, magnetometers detected field strength increases of up to 40% in certain regions, particularly over the Tharsis volcanic province and the ancient, heavily cratered southern highlands. The field enhancements lasted exactly as long as the pulses, returning to normal levels within seconds after each transmission ended. The geographic pattern was non-random. Strongest enhancements occurred over regions with the oldest crustal rocks, areas that had been magnetized when Mars still possessed a global field 4 billion years ago. It was as if the pulses were reactivating ancient magnetic structures, temporarily energizing systems that had been dormant for geological ages. The physics of this made no sense. You can't just turn planetary magnetic fields on and off with radio waves. Magnetic fields require moving charges, electric currents flowing through conductive material. What could 3I Atlas be doing to induce currents in Mars's crust? Phobos, the larger of Mars's 2 small moons, became the focus of intense scrutiny after orbital tracking detected minute changes in its position. Phobos orbits just 6,000 kilometers above Mars's surface, closer than any other moon to its parent planet in the solar system. Tidal forces are gradually slowing Phobos and causing it to spiral inward toward eventual collision with Mars millions of years from now. The orbit is predictable, stable, thoroughly characterized by decades of observation. Then, in mid-May, the orbital predictions started failing. Phobos was arriving at predicted positions several seconds early, a tiny discrepancy, but far outside measurement error. Something was slightly accelerating Phobos in its orbit. The acceleration was minuscule, barely detectable, but it correlated with 3I Atlas pulse timing. During and immediately after pulse windows, Phobos moved fractionally faster than gravitational dynamics alone predicted. The effect accumulated over multiple orbits, creating measurable position errors. The only explanations involved forces acting on Phobos beyond gravity and solar radiation pressure. Either the moon was outgassing, which seemed impossible for a dead rock, or something was pushing it. High-resolution imaging of Phobos revealed nothing obviously anomalous. The moon's surface looked exactly as it had in previous observations. Heavily cratered, covered in regolith, completely inactive. But infrared observations showed thermal anomalies, small regions on Phobos's surface that were warmer than they should be by several degrees. The hotspots appeared on the side of Phobos facing Mars, and their intensity varied with pulse timing. Something was heating specific locations on Phobos's surface, and that something seemed to involve 3I Atlas's transmissions interacting with the moon in ways that generated heat. The implications were staggering. If the pulses could affect Mars's crustal magnetism and influence Phobos's orbit, they weren't just radio transmissions. They were delivering energy to the Mars system, coupling into planetary-scale structures through mechanisms that current physics couldn't explain. And if structures on Mars and its moons were responding to the signals, that suggested those structures might not be entirely natural, that they might have been placed there long ago specifically to respond when the right signal arrived. 3I Atlas wasn't just observing Mars, it was activating something, and whatever it was activating had been waiting on Mars for a very, very long time. Orbital mechanics is one of the most precisely understood areas of physics. Give astronomers an object's position and velocity at any moment, and they can predict where it will be years or centuries into the future with extraordinary accuracy. Gravitational forces follow exact mathematical laws that computers can calculate to arbitrary precision. This is how we land spacecraft on Mars after 9-month journeys, how we predict eclipses centuries in advance, how we know exactly when Halley's comet will return. The math works. It's been tested billions of times and never fails. Except now it was failing with 3I Atlas. The comet's trajectory had been calculated and recalculated dozens of times since discovery. Early observations in January and February of 2025 established its hyperbolic orbit with reasonable precision. By March, with additional data points, the orbit was known well, enough to predict the comet's position months in advance to within a few hundred kilometers. Standard procedure. Then, in late May, the predictions started diverging from observations, not by huge amounts, but by enough that astronomers noticed. 3I Atlas was arriving at predicted positions several thousand kilometers off course. At first, researchers assumed outgassing was the culprit. Comets routinely deviate from pure gravitational trajectories because sublimating ice creates jets that push the nucleus like tiny rocket engines. These non-gravitational forces are small but measurable, and they're expected. Standard comet modeling includes outgassing effects. But the outgassing model requires the comet to be producing gas, and spectroscopic observations showed 3I Atlas's activity declining as it moved away from the Sun after perihelion. Comets moving away from the Sun become less active, not more. Their non-gravitational accelerations should decrease. 3I Atlas was accelerating more than predicted while showing reduced outgassing. The numbers didn't work. By early June, the trajectory discrepancy had grown to over 20,000 kilometers, far too large to explain through modeling errors or undetected outgassing. Analysts trying to fit the observations to orbital models found themselves forced to include acceleration terms that made no physical sense. The comet appeared to be experiencing thrust in directions that didn't align with any outgassing pattern. The acceleration wasn't constant, but varied in magnitude and direction over time, sometimes pointing roughly along the orbit, sometimes perpendicular to it. The most disturbing finding came from detailed analysis of the acceleration vectors. The trajectory changes appeared to be steering the comet, not randomly, not following the chaotic patterns of asymmetric outgassing, but steering toward a specific destination. Projecting the altered trajectory forward showed 3I Atlas was now on course to pass significantly closer to Mars during a second approach in late June. The original orbit would have carried it past Mars at a distance of roughly 40 million kilometers on the outbound leg. The new trajectory would bring it to within 15 million kilometers, nearly 3 times closer. This wasn't possible through any natural mechanism. Outgassing can change a comet's trajectory, but it can't navigate. Navigation requires sensing your current position, calculating the trajectory change needed to reach your destination, and applying thrust in the correct direction at the correct time. These are engineering tasks, not natural processes. Yet, 3I Atlas was apparently doing exactly this, adjusting its course to set up another close pass by Mars. The physics-breaking nature of the maneuvers became undeniable when calculations showed the energy required. The observed trajectory changes require delta V, change in velocity, of roughly 200 meters per second. For a comet, nucleus estimated at several billion tons, that represents enormous momentum change. The kinetic energy involved exceeded any plausible outgassing scenario by orders of magnitude. Something was pushing 3I Atlas, something far more powerful than sublimating ice. And whatever it was under intelligent control, executing a flight plan that brought the comet back toward Mars for a second, closer look. The object wasn't just signaling, it was maneuvering, and it was coming back. The discovery that changed everything came not from professional observatories, but from an amateur astronomer in Australia conducting routine observations of the asteroid belt. On June the 3rd, 2025, while imaging asteroids in the region between Mars and Jupiter, the telescope captured something impossible. One of the asteroids was emitting radio signals, not reflecting solar radiation, not producing natural emissions from thermal processes, but broadcasting structured electromagnetic pulses nearly identical to those from 3I Atlas. The asteroid designated 2011-UW158 had just activated, and it wasn't alone. Within 48 hours of the initial report, observers worldwide had identified 17 additional objects in the solar system showing anomalous electromagnetic activity. Most were asteroids in the main belt, but 3 were trans-Neptunian objects in the outer solar system, and 2 were near-Earth asteroids that had been catalogued decades ago and showed no unusual characteristics until now. Every activated object was transmitting pulses with similar frequency and and timing characteristics to 3I Atlas. The patterns weren't identical, but they were clearly related, like dialects of the same language or nodes in the same network. The implications were staggering. If nearly 20 solar system objects were actually dormant probes or monitoring stations, how many more existed that hadn't activated yet or were too small to detect? The asteroid belt alone contains millions of objects larger than 1 kilometer. The Kuiper belt and scattered disk beyond Neptune hold billions. If even a tiny fraction were artificial, placed by whoever sent 3I Atlas, or by multiple civilizations over millions of years, the solar system might be saturated with surveillance infrastructure that humanity had been cataloguing as natural objects for decades. The activation timing suggested communication between objects. 3I Atlas began signaling in March. By June, objects throughout the solar system were responding, waking from dormancy after potentially millions of years of silence. Either they were responding to 3I Atlas's signals directly, which implied reception capabilities across billions of kilometers, or they were responding to something 3I Atlas had triggered in the Mars environment, some change in planetary conditions that served as an activation signal for the entire network. Detailed observations of the newly active asteroids revealed characteristics that had been hiding in plain sight. Their spectral signatures, the reflected sunlight that astronomers use to determine surface composition, showed unusual features in the infrared that had been attributed to rare mineral compositions. Now those features looked more like thermal emissions from power sources maintaining operating temperatures inside the objects. Their shapes, determined from brightness variations as they rotated, showed geometric regularities unexpected for natural fragmentation products. They were too smooth, too symmetric, shapes that minimized surface area for a given volume. Exactly what you'd design if you wanted to reduce cosmic ray damage and micrometeorite impacts over geological timescales. The orbital distributions also looked suspicious in retrospect. Several of the activated objects occupied stable resonance orbits, positions where gravitational interactions with Jupiter kept them in configuration for millions of years with minimal orbital evolution. These are ideal parking orbits for long-term monitoring stations, positions that require almost no station-keeping energy to maintain. Natural asteroid capture into these resonances happens, but is relatively rare. Having multiple activated objects, all in resonant orbits, exceeded reasonable probability for coincidence. The most unsettling observation came from comparing activation times with current planetary positions. The objects that activated first were those with the most direct line of sight to Mars. Activation propagated outward at approximately the speed of light, suggesting the trigger signal originated from Mars or from 3I Atlas near Mars, and spread through the system at electromagnetic wave velocity. The network was waking up in a pattern consistent with signal propagation, each node receiving instructions and powering up in sequence. Humanity suddenly found itself living in a solar system that had been under observation for unknown duration by unknown observers using infrastructure that had been catalogued as natural objects. The probes had been here all along, sleeping among the asteroids and ice. 3I Atlas hadn't invaded. It had come home and woken up the family, and now they were all watching us together. The breakthrough came at 3 in the morning on June the 9th, 2025, in a cluttered office at the SETI Institute in California, where a researcher had been analyzing the combined signal data from 3I Atlas and the activated asteroid network for 11 consecutive hours. The pattern had been there all along, hidden in plain sight, waiting for someone to look at the data in exactly the right way. When the pieces finally clicked into place, the researcher sat frozen for several minutes, staring at the screen before reaching for the phone to call colleagues who needed to see this immediately. The key was treating all the active objects as a single distributed transmitter rather than independent sources. Each object was broadcasting pulses on slightly different schedules and frequencies, which had made the individual signals seem unrelated beyond their basic similarity. But when you synchronized the signals using their activation times as reference points and accounted for light travel delays between objects, a higher order pattern emerged. The individual transmissions were components of a single massive message being broadcast across multiple channels simultaneously. It was like listening to one instrument in an orchestra and hearing noise. But when you combined all the instruments together, you got symphony. The synchronized signal contained embedded mathematical sequences that were unmistakable once you knew to look for them. The first sequence was the prime numbers from 2 through 97, transmitted as pulse count groupings that couldn't be mistaken for anything else. Primes are the universal handshake, the mathematical equivalent of saying we know you're intelligent, because only intelligence counts in primes. But the message didn't stop there. After the prime sequence came the Fibonacci sequence, where each number equals the sum of the previous two. Then came powers of 2, the exponential sequence, fundamental to information theory and binary computing. But the real message was in what came after, the mathematical greeting sequences. A series of timing ratios appeared that initially seemed random until someone recognized them as approximations of fundamental physical constants. The ratio between certain pulse intervals matched the fine structure constant to 4 decimal places. Other ratios corresponded to the mass ratio between protons and electrons, to the gravitational constant in natural units, to the Rydberg constant that governs atomic spectra. The message was encoding the laws of physics, demonstrating knowledge of how the universe works at the most fundamental level. Then came coordinates, a sequence of numbers that made no sense until analysts realized they were spherical coordinates, angular positions that specified directions in space. When plotted, the coordinates traced out a 3-dimensional map showing the positions of stars within roughly 50 light-years of the Sun. Each star was marked with a number, a ranking or identifier of some kind. The Sun was marked with the number 43. The implication was clear. This was a map of surveyed stellar systems, and Sol was number 43 on someone's list of explored or monitored stars. The final section of the message was the most puzzling and potentially the most important. A long sequence of binary data, zeros and ones encoded in pulse timing, containing roughly 64 kilobytes of information. The structure suggested an image or diagram, but determining the correct width and height to render the data required guesswork. Researchers tried various configurations, rendering the binary data as images with different dimensions. Most produced noise, random static with no recognizable features. But when rendered as a square image, 512 pixels on each side, a picture emerged. The image showed a planet, unmistakably a planet, with continents and oceans and polar ice caps. But it wasn't Earth. The continental shapes were wrong, the ocean distribution different. It looked like Mars, but not current Mars. This was Mars with liquid water on its surface. Mars as it had been 4 billion years ago, before it died. And superimposed on the ancient Martian surface were markers, dozens of them, indicating specific locations on the continents and beneath the ancient seas. 3I Atlas wasn't just studying Mars, it was showing us where to look. June the 26th, 2025. That was the date astronomers had been dreading since trajectory calculations showed 3I Atlas performing course corrections. The comet was approaching solar conjunction, the point where it would pass behind the Sun from Earth's perspective, disappearing into solar glare where no telescope could track it. For roughly 3 weeks, humanity would lose direct observation capability of the object that had upended our understanding of our place in the universe. And everyone watching understood that when 3I Atlas emerged from behind the Sun, if it emerged at all, it might be in a very different position than orbital mechanics predicted. The comet had already proven it could maneuver. There was no guarantee it would follow predictable physics while hidden from view. The final observation window produced a frenzy of activity unprecedented in astronomical history. Every available telescope pointed at 3I Atlas, collecting data at maximum rate, storing observations that would be analysed for years regardless of what happened next. The comet was now roughly 70 million kilometers from Earth, close enough that even modest amateur telescopes could detect it as a fuzzy patch of light. Professional observatories captured images showing the nucleus resolved as a distinct point separate from the surrounding coma, measuring photons that had bounced off an object that might be the most important discovery in human history. The pulses continued unabated right up until the last moment of visibility. The pattern had stabilized after the changes in May, settling into a new rhythm of 5-hour, 12-minute intervals that the activated asteroid network echoed with precise synchronization. The signal strength was declining as the comet moved farther from Mars, but the precision remained perfect. Whatever power source drove the transmissions showed no signs of degradation despite months of continuous operation. The electromagnetic signature remained narrow-band, centered near the hydrogen line, optimized for interstellar communication in ways that still seemed almost too convenient to be coincidental. Spectroscopic observations in the final days revealed one more anomaly to add to the growing list. The unidentified emission lines that had appeared in early spectra were changing, their intensities increasing, while their wavelengths shifted slightly toward the blue. Something in the comet's composition was being excited to higher energy states, glowing more brightly as if powering up for something. Theoretical models couldn't explain the changes using any known comet chemistry. The lines looked more like emission from a fusion reactor ramping up power output than anything that should appear in a dirty snowball. Radar observations from Goldstone and Arecibo got priority during the final week. The radio telescopes bounced signals off 3I Atlas's nucleus, measuring its rotation rate and detecting any changes in size or shape. The nucleus appeared unchanged from earlier radar observations, still roughly spherical, still about 25 kilometers in diameter, still rotating with an 18.3-hour period. But the radar returns showed something new in the final observations. Specular reflections, bright radar echoes from smooth, flat surfaces that shouldn't exist on a natural comet nucleus. The surfaces were small, perhaps a few hundred meters across, but they reflected radar with an efficiency that suggested metal or some other highly conductive material. Natural comet surfaces are rough and absorptive. These reflections indicated engineered structures, panels or antennae, or something else entirely. Geometric shapes embedded in or protruding from the ice. On June the 26th, at approximately 1400 hours, Universal Time, 3I Atlas transmitted its final observable pulse before disappearing into solar glare. The transmission was different from all previous pulses, lasting nearly 30 seconds instead of the usual 5 or 6. The signal contained massive amounts of data, far more information than any previous transmission. Analysts would spend weeks decoding it, but preliminary analysis showed it was another image, much higher resolution than the Mars map, showing something that looked like technical diagrams or schematics. Instructions perhaps, or warnings, or a blueprint for something we were supposed to build or find. Then silence. The comet vanished into the sun's overwhelming brightness, and every telescope that had been tracking it for months suddenly had nothing to observe but empty sky and solar glare. The asteroid network continued transmitting for another 48 hours. Then it too went silent. Every activated object powering down simultaneously as if responding to a final command from 3I Atlas. The symphony ended mid-note, leaving humanity in silence, waiting to see if the conductor would return, or if the performance was over. 3 weeks until the comet should emerge on the other side of the sun. 3 weeks to wonder if it would still be there when the glare cleared. 3 weeks to prepare for whatever came next, knowing we were probably not prepared at all. The 3 weeks, while 3I Atlas A remained hidden behind the sun, felt simultaneously endless and too brief. The world had changed in ways both obvious and subtle, and there was no going back to the comfortable assumptions that had governed human civilization for its entire existence. We were not alone. We had never been alone, and the implications of that realization were rippling through every aspect of society, from science funding to religious doctrine to international relations. NASA's budget request for the following fiscal year included line items that would have been inconceivable 6 months earlier. Planetary defense got a massive increase, not for deflecting asteroids, but for developing the capability to reach and study interstellar objects on short notice. The proposal included funding for a fleet of rapid response spacecraft that could be launched within weeks of detecting a new interstellar visitor, capable of reaching the object and performing close-up observations before it left the solar system. The European Space Agency proposed similar programs. China announced plans for its own interstellar object intercept mission. The space race had returned, but this time the competition was about who could study alien artifacts most effectively. Academic institutions restructured almost overnight. Universities created new departments dedicated to studying potential non-human intelligence and technology. The field needed a name, and after heated debate, the term xenotechnology gained acceptance for the study of artifacts from non-human civilizations. Tenure-track positions appeared at major universities seeking experts in xenotechnology, a field that hadn't existed 4 months ago. Graduate programs developed curricula combining astronomy, engineering, biology, and anthropology into frameworks for understanding intelligence that might operate on completely different principles than human cognition. SETI, the search for extraterrestrial intelligence, found itself suddenly relevant and funded after decades of struggling for recognition and money. Governments and private donors who had dismissed SETI as fringe science were now throwing resources at expanding the search. New radio telescope arrays got funded specifically for monitoring the solar system for signals from objects we'd previously assumed were natural. Every asteroid, every comet, every piece of space debris larger than a few meters became a potential probe that needed monitoring. The catalogue of solar system objects had transformed from a navigation database into a surveillance target list. Religious institutions grappled with theology in an age of confirmed alien presence. Some traditions adapted smoothly, incorporating the discovery into existing frameworks about divine creation extending beyond Earth. Others struggled more profoundly, particularly those whose cosmologies placed humanity at the center of divine attention and purpose. Interfaith councils convened to discuss appropriate responses. The Vatican issued a statement acknowledging that the existence of non-human intelligence posed no challenge to Catholic doctrine, that faith and the reality of a populated universe were entirely compatible. Other religious authorities remained silent or divided, their followers debating implications in temples and mosques and churches worldwide. The educational system began adapting. Textbooks were being rewritten to reflect new reality. The solar system chapter now included sections on dormant monitoring networks and interstellar visitors. The question of whether we're alone in the universe had been answered definitively, and curriculum at every level needed updating. Children born after the 3I Atlas discovery would grow up in a world where alien intelligence was established fact rather than speculation, and their education would reflect that reality from kindergarten forward. International cooperation on space matters improved in some ways and deteriorated in others. The United Nations convened a special committee on extraterrestrial contact protocols, attempting to create frameworks for unified human response to future contact scenarios. Progress was slow, hampered by national interests and disagreements about decision-making authority. Who speaks for Earth remained an unresolved question, but at least the question was being asked officially, rather than only in academic papers. Popular culture absorbed the discovery with characteristic speed. Movies and television shows that had depicted alien contact as distant speculation suddenly seemed prophetic or quaint, depending on how they'd imagined the scenario. Science fiction conventions saw attendance spike as people sought communities where discussing alien intelligence had always been normal. The boundary between science fiction and science fact had blurred to near invisibility, and nobody was quite sure how to navigate a world where yesterday's impossible speculation was today's documented reality. The paradigm had shifted. Humanity was no longer alone, no longer the only known intelligence, no longer living in cosmic isolation. Every assumption built on human uniqueness now required re-examination. Every plan for humanity's future now had to account for a galaxy that might be crowded with civilizations far older and more advanced than ours. We waited for 3I Atlas to emerge from solar conjunction, but regardless of whether it reappeared, the world it had revealed could never be hidden again. July the 18th, 2025. That was the date when 3I Atlas should emerge from behind the Sun based on pre-conjunction trajectory calculations. Observatories worldwide had cleared their schedules for the recovery attempt, coordinating observation plans that would maximize the chances of detecting the comet the instant it became visible again. But there was a problem. Nobody knew exactly where to point their telescopes. The comet had demonstrated maneuvering capability before disappearing. It might emerge exactly where calculations predicted, or it might have changed course during the conjunction period and appear somewhere completely different. The recovery search would need to cover a large area of sky, and even then might miss the comet entirely if it had maneuvered significantly. The emotional atmosphere in the astronomical community during those final days before expected emergence resembled the tension before a major rocket launch. That mixture of excitement and dread, where you desperately want to see what happens, but fear that something might go wrong. Some researchers privately admitted they hoped the comet wouldn't reappear, that it would have left the solar system during conjunction, ending the episode and allowing humanity to return to some semblance of normality. Others desperately wanted it to come back, wanted answers to the 1,000 questions raised by the mathematical message and the Mars map and the spectroscopic anomalies. The waiting was agony, regardless of which outcome you preferred. Search protocols divided the sky around the sun into sectors, assigning different telescopes to monitor different regions. Space-based observatories like Hubble and James Webb got priority assignments because they could observe closer to the sun than ground-based telescopes, seeing into the solar glare that blinded instruments operating through Earth's atmosphere. Solar observing spacecraft like SOHO and Solar Orbiter were positioned to potentially catch the comet if it passed close to the sun. The net was as comprehensive as resources allowed, but space is vast, and 3I Atlas was small. If it was hiding deliberately or had maneuvered into an unexpected orbit, the recovery search might take days or weeks rather than hours. July the 18th arrived. Observatories began their searches at the calculated emergence time. Hours passed with no detection. The expected position was covered thoroughly, imaged multiple times by multiple facilities. Empty sky, nothing at the predicted coordinates. As the day wore on without detection, the search expanded to cover larger areas, checking positions the comet might occupy if it had performed moderate trajectory changes during conjunction. Still nothing. Social media filled with speculation. Had 3I Atlas left the solar system? Had it crashed into the sun? Was it hiding deliberately, observing humanity's response to its disappearance? Or had it never been under intelligent control at all? Just a natural object with weird properties that had coincidentally stopped being weird when it passed out of view. The detection came 36 hours late and 4 million kilometers off the predicted position. A small observatory in Chile captured it first, a faint smudge of light exactly where it shouldn't be if it had followed natural orbital mechanics during conjunction. The discovery triggered immediate follow-up observations from larger facilities, confirming the identification through spectroscopy that matched 3I Atlas's unique emission lines. The comet had returned. It was still active, still transmitting, though the pulses had changed yet again, now following a 10-hour interval on a completely different frequency, and its trajectory had altered dramatically. Rapid orbit determination showed 3I Atlas was now on a course that would take it back out of the solar system, not following its original hyperbolic orbit, but on a new trajectory that seemed almost deliberately chosen to pass near specific asteroid belt objects, several of the same asteroids that had activated during the June network awakening. It was making a tour, visiting the other probes, or perhaps collecting them. Radar observations over subsequent days confirmed the comet was accelerating, pushing itself onto the new trajectory using methods that still violated known physics, but were now undeniably real. The second surprise came when analysts decoded the new pulse pattern. It was another message, this one simpler and more direct than the elaborate mathematical transmission from June. Rendered as binary data, it formed a simple sequence, a countdown. Numbers descending from 100, transmitted one number per 10-hour pulse cycle. The comet was counting down to something, giving humanity roughly 1,000 hours, about 41 days, until whatever it was counting down to reached zero. Nobody knew what would happen when the countdown ended. The mathematical message hadn't explained that part, or if it had, we hadn't decoded it correctly. 3I Atlas was still talking to us, still sending signals, but now it had given us a deadline. 41 days until the count reached zero. 41 days to prepare for contact, confrontation, transformation, or possibly nothing at all. The comet had returned, but the mystery had only deepened, and the clock was ticking down. The universe suddenly feels different. Not physically, the stars still shine in the same patterns. Planets still orbit according to Kepler's laws. The cosmic microwave background still whispers its story of the Big Bang across the sky. But psychologically, everything has changed. The silence that Fermi pointed to, that absence of obvious alien civilizations broadcasting their presence across the galaxy, no longer feels like evidence that we're alone. It feels like evidence that someone is being very quiet on purpose. And if 3I Atlas is any indication, they're not staying home around their stars. They're traveling, they're watching, and they've probably been here longer than we have. Look up on a clear night and try to see the sky the way you saw it before March of 2025. You can't. Every point of light, every wandering planet, every faint smudge that might be a comet carries the weight of possibility now. How many of those objects are exactly what they appear to be? And how many are something else? We've catalogued hundreds of thousands of asteroids, charted their orbits, classified their compositions based on reflected light. Before 3I Atlas, we assumed they were all natural, all debris from planetary formation 4.5 billion years ago. Now, we know that assumption was wrong for at least 20 of them. And if 20, then why not 200? Why not 2,000? The solar system we thought we knew has become strange territory, populated by objects whose true nature we can no longer take for granted. The countdown continues as this is written. 3I Atlas transmits its descending numbers every 10 hours with the same precision it brought to every previous signal. 93, 92, 91. Humanity watches and waits and prepares as best we can for an event whose nature we can only guess at. Some think the countdown marks the arrival of additional objects, a fleet of interstellar visitors converging on the solar system. Others believe it's counting down to activation of something already here, perhaps structures on Mars that have been dormant for billions of years, waiting for the right signal to wake them. Still, others argue it might be counting down to the comet's departure, a final timeline before 3I Atlas, and its network shut down and return to dormancy or leave the solar system entirely. The deeper question transcends the countdown and 3I Atlas itself. We now know the galaxy is more complex than we imagined. That interstellar space contains travelers, that solar systems might routinely host monitoring equipment placed by civilizations we've never contacted. But knowing these things exist doesn't tell us why. What is the purpose of this network? Is it scientific exploration? Cosmic anthropology conducted on galactic scales? Is it preparation for something? Surveillance to determine which civilizations are ready for contact? Or is it darker, monitoring for threats, identifying species that might become dangerous before they spread beyond their home systems? The Fermi paradox asked where everybody is. 3I Atlas suggests an answer. They're not advertising their presence with powerful broadcasts. They're not building Dyson spheres or other megastructures visible across light years. They're being subtle, hiding among natural objects, watching quietly. Perhaps every civilization that survives long enough learns to be cautious, learns that broadcasting your location might attract attention you don't want. The galaxy might be full of civilizations, all hiding from each other, creating a collective silence, punctuated only occasionally when someone decides to break it. We broke it. Our radio and television broadcasts have been leaking into space for over a century. We've sent deliberate messages to nearby stars. We've marked our presence obviously enough that any civilization with modest technology and interest in this region of the galaxy knows we're here. 3I Atlas responded to our noise by revealing itself, by activating its network, by starting a countdown to something. We got there. Attention. Now we wait to learn whether that was a wonderful achievement or a terrible mistake. Future cosmic dates take on new significance. Every predicted close approach of an interstellar object, every unusual asteroid that shows up in surveys, every anomaly detected in the outer solar system becomes potentially significant. We're watching now, really watching, with the awareness that the solar system is not the empty stage we thought it was. The next visitor might arrive next month or next century. The countdown might reach 0 and nothing obvious will happen. Or it might mark the moment when everything changes, when contact shifts from cryptic signals to direct interaction, when we finally learn what 3I Atlas and its creators want from us. The stars are still silent, but the silence no longer feels empty. It feels like the quiet before something speaks, the pause before an answer, the breath before the song begins. 3I Atlas broke the silence. And whatever comes next, we're as ready as a young civilization can be when it finally learns it's been living in a populated galaxy all along.